Alright, so we've been looking at dissolving the last couple days in class. Today we're going to look at the molecular level, what's going on at super tiny scales that's affecting how things dissolve. So take a closer look. So oxygen, pretty simple molecule. Sorry, this is water. Great big oxygen, two little hydrogens. The fun thing about water is that it has positive and negative ends. The oxygen has this negative charge to it, the two hydrogens end up positive. So it makes water really interesting because water likes to bond together. It likes to make these really big networks. You see these in snowflakes. Those are part of the structure of water interacting. So we're going to ignore the 8s and the sigmas and the 1. But we see how the positives of the hydrogen line up the negatives in the oxygen. This turns out to be really important for why water is so good at dissolving things. So when you drop a sugar molecule in water, there's lots of parts of, there's lots of parts of sugar that also have these positives and negatives. So water loves to crowd around it and interact with it, just like we saw in the video about water and salt. They like to dance together. Same thing happens. So the water moves in, starts breaking apart the crystal. You see it here, I'm pulling them apart over time. So water loves to do this because sugar has a lot of positive and negative parts to it, just like it does. We saw with temperature, when temperature increased, things dissolve faster. It means the motion of water was going faster and faster and faster. So it's able to tear apart the sugar molecules into their smallest parts faster. It could get into the crystal faster. Below the other solvents, we saw vegetable oils. These are huge molecules. All the oils are very large molecules. The only thing important here with this diagram is over here we see the oxygens again, the hydrogen. This is the only part that ends up with a positive in the hydrogen and negatives in the oxygen. So most of vegetable oil doesn't have these positives and negatives. This is why, as we saw, water and oil don't like to mix together because they don't have the positives and negatives in the same way. Something similar happens with isopropyl alcohol, rubbing alcohol. It has a little bit of positive and negative. Positives here, negatives here, but they're in the middle. They're not all around like in oxygen, like in water. So we see again the effect of the solvent is huge as to whether it can dissolve or not. So we look at the effects of dissolving. So in closing, we could say water has positives and negatives because of its structure with oxygen and two hydrogens, and likes to dissolve other things that have similar positives and negatives like sugar and salt, but not like oil. As temperature goes up, things move more. In fact, that's what temperature is. And things dissolve faster because they're moving around quicker. And different solvents have different areas where they're polar, where they have positives and negatives, and that affects they're able to dissolve. We'll talk about all this in class tomorrow. So thanks for watching and have a great rest of your night, guys.